Okay, so now we want to talk about some notation and sort of some more mathematically rigorous stuff here. So suppose we have some curve like this and we want to find the area under that curve, and hopefully we have an idea of why we might want to find the area under the curve. We've got finding distance traveled, finding displacement, maybe finding the amount of blood that you're given if you know the flow rate. So there's really lots of different reasons why we'd want to do that, or perhaps maybe even the rate of snow, and we want to see how much accumulates so that we can figure out whether we're going to have a snow day again. So what we can do is say, all right, let's pick some interval. So let's start this thing at A, and let's go to B. So we've got an interval, and the interval length is basically B minus A. And so that's fine. Let's say we want to use a few rectangles. So let's cut it up into 5 different rectangles. Okay. So then we'd have some rectangles here, and that would be a rectangle, 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 rectangle. So that would be our rectangle width. So the width of each one of these rectangles, if I had cut it up perfectly, which I didn't, but the width would be the whole interval, which is B minus A, divided by 5, right? That would be this width right here. So when I cut it up into 5 rectangles, I should get basically a width of B minus A over 5. So this is the interval. We call these subintervals. So we say this would be 5 subintervals. Okay. We could have more though, right? And that's one idea of making this a better approximation. We really could have n subintervals. And if we had n subintervals, then the width would be basically B minus A over n. So if we wanted to have lots, 10, 20, 30, 100, maybe a million subintervals, then it would just be B minus A over a million, or B minus A over n. So we might think about too, like what happens, right? What happens to B minus A over n as n approaches infinity, right? If we have lots and lots and lots and lots and lots of rectangles, what happens to the width? Well, the width of the rectangle goes to 0, right? And that's really what we want. We want infinitely many rectangles with a tiny, tiny, tiny width. So in general here, if we call, let's call this right